As the very name suggests, while selection sorting, we select out of a given list of elements, we select the smallest element and put it in the first position. Then we select the next smallest, put it in the second position. Then we select the third smallest, put it in the third position, and so on. And we continue doing this. So supposedly, if I'm having a random list, so within this list, now since I'm talking about data structures and algorithms here, so I am keeping the numbering from 1, which is not representing any language. If you are going to implement it, please make sure you are converting the numbering to zeros. I am going to take the algorithms here today. So in algorithms, we are talking about layman terms. In case you will be implementing them, kindly make the changes accordingly. So these are the indexes 1, 2, 3, 4, and 5 and 6. 6 elements are there in the array. I pick up the first element or smallest element. What is the smallest element? 1 is the smallest element. So what I do is I exchange the smallest with the first position. So after the first pass, I will compare. I'll find out smallest, smallest, smallest. What I do is initially I say that smallest is equal to the first element, which is a of 1. Okay. Then I keep on checking. I check if the smallest element a of I is less than the smallest, then kindly update the smallest. So what am I doing is, smallest is 5 initially. So I check 5 less than 10, continue. 5 less than 7, continue. 5 less than 1, no. That means smallest was initially 5. Now location, smallest is the element here. I am taking the location of the smallest element, which initially is 1. So if I am having that 5 is less than 1, then I need to update the location of smallest element. So I update the location of smallest element to be 4. I again continue. Now 4 इसके आगे से continue करेंगे. 4 less than 2, again not true. Sorry, a of 4, that means this is 1. 1 less than 2 is true. Smallest की position है 4. 1 is less than 2 is true. 1 is less than 8 is also true. So I have found the smallest element to be 1. So after the first iteration, what I will do is I will exchange a of smallest with the position a of 1 or a of I technically. अभी I1 ले रखा है हमने. Okay. So after swapping, after the first pass, what will happen? 1 comes here. 10, 7 remain here, 5 comes here, 2 and 8. So after the first pass, what has happened? The smallest element has come in here. Now this is the remaining array. I repeat the same procedure. I pick up the smallest element and swap it with the second element. So the smallest here is 2. I will be swapping 2 with 10. How do I find the smallest once again? This is 1, 2, 3, 4, 5 and 6. The indexes will remain same. Now I am beginning with 2. So the position or index of smallest is initially 2. So 10 is there. So I compare. 10 is less than 7. No, I need to shift the smallest. So smallest is shifted. Smallest becomes 3. Right? The index. Smallest is storing the index of the smallest. Again, I am checking 7 less than 5. Again, no. Smallest is again updated. Smallest is updated to be 4. I again check. 5 less than 2. Again, no. Smallest is again updated to be 5. I again check 2 less than 8. This is correct. So smallest is now at 5th location. So kindly exchange A of smallest with A of I. I is now 2. So exchange 2 with 10. So after the second pass, 2 elements have been sorted. Again pick up the smallest element and exchange with the next, and keep on doing this till the entire array is sorted. This procedure is called as the selection sort procedure. And if you want to write an algorithm for selection sorting, so let us write an algorithm for selection sorting. I'm writing the selection sort procedure. This is an algorithm again. It is not language specific on an array or a list of elements in A. So initially, the first step is that I'm calculating the length of the list. List might be stored as an array or whatever method you are using. This is sorting. The sorting can apply to an array, it can apply to a linked list, anything. Although we are talking about arrays here. Then I'm running a loop here for, I'm running I is running from 1 first से लेके n minus 1 तक, because after that you will not be able to compare ना. So I is running from 1 to n minus 1. What do I need to do? Now here I need to make smallest is equal to I. Smallest is equal to I. That is what I have been doing. And I am taking another loop while I can take another loop variable, supposedly say j. So I am having for j is moving from I plus 1 to n. J is moving from the next element till the last element. If now, then again, this is within the for loop. So if a of j is less than the a of smallest, that means smallest has to be updated. So I update the smallest to be j. Smallest is updated to be j. After I'm done, after all of them have been checked, smallest will be having the location of the smallest. So when I come out of this for loop, I will be doing an exchange or swapping of the values for a of I with a of smallest. And I keep on doing this till all the values, and finally my procedure is over. This is the only selection sort algorithm. If I am running this algorithm here, I'm again saying this is the outer for loop. If you want to put the brackets, this is the inner for loop. The exchange is happening after the inner for loop is over. So what is happening? I have dry run the same procedure here. Initially I is 1, smallest is equal to I, j is I plus 1. So I'm checking with the smallest is checked with the next element. So I'm checking a of 2 with the smallest, a of 3 with the smallest, a of 4 with the smallest, and so on till I'm having the smallest of the entire list. When this is over, smallest of the list is there, and I exchange the ith location with the smallest. So first pass mein first element is, smallest element is selected and put it in the first position. You go again, you increment I, again do the same procedure and continue doing it. This is known as selection sorting procedure. If you look at the complexity of this procedure, the outer loop here, this loop is running for n minus 1 times. The outer loop here is running for n minus 1 times. And the inner loop here is running again for n minus 1 times. If you can see that. Maximum, although this will keep on decreasing. So on an average, I can say if I am going to add all of these terms, if I add them respectively, so I have to add the constant time taken by these. n minus 1 times chalega, फिर n minus 2 times chalega, फिर n minus 3 times chalega, and so on. So I need to add all of them. That is n minus 1 plus n minus 2 plus n minus 3 plus so on. So this is nothing but a sum of a series. First n minus 1 natural numbers, that n into n plus 1 by 2 hona chahiye, that is not here, so it comes less. So I'm just keeping on adding. So what is happening here, this is running till of the odd. All iterations के लिए it is running n minus 1 into n by 2. n into n plus 1 by 2 होता है ना. So this is how many times the loop is going to run for all the outer iterations of the loop also. So the complexity is coming out to be of the order n square only. Or if you don't want to do like this, simply nested loop hai, you multiply the complexity. So n minus 1 ka whole square karoge, that's also of the order n square, comes out to be the worst case or even average case complexity of selection sort. Now even in average case, supposedly the list is sorted, चाहे sorted list हो तब भी आपको for loop पूरा रन करना पड़ेगा smallest element को pick करने के लिए, चाहे unsorted list हो. It is possible that you are not doing this swap, but this if condition is checked always. Even if it is a sorted list, then also the smallest element will be picked and one will be replaced with one itself, and so on and so forth will continue. So in best case or in average case or in worst case, the complexity would remain of the order n square time only. Is it clear to all? So selection sorting key average, best, worst, sub complexity would remain of the order n square. Is it clear to all of you?